Okay, so today we're going to learn Unit 4 Continued Part 2. We're going to start with Lesson 1, which is factoring polynomial expressions with degree greater than or equal to 2. We have three types of factoring that we're going to cover today. First, sum and difference of cubes. Second, quadratic form of polynomials. And third, grouping. First example, sum and difference of cubes. The first thing I would like you to do is figure out what a perfect cube is. Okay, so let's make a chart with a base. Okay, and the base cube. So we'll call this B, and then we'll call this B cubed. Okay, we'll do a few numbers and a few combinations of letters and numbers. 1, -1, 2, 3, 4, 5. Okay, let's start combining some. Let's do maybe 3x. Let's do maybe 2x squared. Okay, so in order to cube, you take this quantity, multiply it 3 times, and fill it in. Okay, press pause, fill in the rest of the box, and then check your answers. Nice job. Hopefully you got those right. Be careful that the -1 actually still stays negative. Let's try a couple more with just variables. Z cubed x. If we want to cube that, that's the same thing as saying this, which means write the quantity 3 times and multiply it. Hopefully you remember your exponent rules, so we get z, 1, 2, 3, 4, 5, 6, 7, 9, x cubed. Okay, let's try one more. Negative x to the 4th. Okay, so negative times negative times negative is still negative. X to the 4th times x to the 4th times x to the 4th is x to the 12th. Next thing we're going to do is multiply cubes together. Okay, first example, x minus 3 cubed. Now, first thing I want you to do is actually write the quantity 3 times. What you're going to do when you have 3 things together is pick 2 at a time and multiply. First, outer, inner, combines to minus 6x. Last, plus 9. Okay, continue multiplying. Okay, first by distributing the x, next by distributing the minus 3. And combine your like terms. Notice that this does not simply combine to what you think of as the first term is x cubed and the last term is negative 3 cubed. Notice you still have the middle quantities that you have to find. In example B, we looked at multiplying with a cube power. This time we're going to look at factoring with a cube power. If you are given 2 perfect cubes, let's start with a cubed minus b cubed. Notice first that the exponent is in a different place, and so is the grouping symbol. There is a formula in order to remember how to factor this expression. Okay. Notice first that you need to consider the base. A cubed, the base is a, and the base is b. The first factor, you will copy the 2 bases over, and you will use the same sign. The second factor is longer and a little bit harder to remember. Okay, so I'm going to put my finger on the A. A squared. A times B. B squared. And then you have to remember the signs. Okay, so let's check. Negative, positive, positive. Okay, the first sign is negative because it's the same as the one you started with. The next sign is opposite, and the last sign is always positive. Okay, we have a synonym. We have a saying that helps us remember that. It's called SOPs. For square, square the first term. Opposite, product, square. Okay, so let's do an example. X cubed minus 64. The first thing you have to do is determine the perfect cube and its base. Okay, so the base is x and the base is 4. Okay? This will factor. Fill in the first factor. Okay, x minus 4. Next factor. Okay, here we go. Square the first one. Okay, x times x. Multiply opposite sign. Plus 4 times x. Square the last number. Even if you consider the negative, negative times negative will be positive. This is completely factored. You can try factoring this quadratic, but it will be prime every single time. Okay? You try. Determine the base A and B, and then create the two factors. Check your work. Notice that 2 cubed is 8, x cubed is x cubed, and 3 cubed is 27. The first factor are the two bases with the same sign. The next factor, as you can see, square, opposite product, square. Another way to remember this is a kinesthetic way. You can actually tap your paper 3 times. Notice 1, 2, 1, 2. This is a sum and difference of cubes formula. Each base is used 3 times, which helps you remember. Also notice that this factor has 3 terms in it. So when you are factoring sum or difference of cubes, the first factor is copying the bases over. The second factor has 3 terms. Now let's go ahead and look at the sum of cubes. Okay, the formula will be very similar. Consider the bases, A and B. This first factor, copy the bases and use the same sign. The second factor, okay, here we go. A squared. Opposite, product. Opposite is for the sign, product is for multiply. Square. Consider these two formulas should be committed to memory. Okay, the sum formula and the difference formula. Okay, let's do one example. Perfect cube. Think back to that list. Okay. Let's throw in another letter here. Okay, first, identify the bases. Use the formula, fill out the remaining factors. First factor should be 4x plus z. Now for the second factor. Okay, 4x times 4x is 16x squared. Opposite signs, 4x times z, and then z times z. Congratulations, this is the end of the sum and difference formula. Let's try putting it all together in an example that requires more than just this formula. Factor completely. Remember your factoring flowchart. First thing we have to do is look at GCF, greatest common factor. Second thing are pairs or patterns. Seeing as how this is where we've stopped, this is all we need to check. Do you have a GCF to consider? Yeah, GCF of 2. Now that I've done the GCF, I see that there are perfect cubes. I've identified my bases, and I will finish by writing out the formula. Okay, ready for my second piece. I'm actually going to tap the paper to help me remember. Congratulations. Here's one more for you to try. Okay, negative x to the 6th plus 1. Okay, at first I don't really see any patterns, but I do see a negative leading coefficient, so I'm going to factor that out first. I see a pair of terms. Now I notice that x to the 6th is a perfect cube, so I'm going to identify those bases. Remember, right? Repeated 3 times, that's a perfect cube. And 1. Okay. Copy the first factor. Okay. Okay, let's do the second one. X squared times x squared is x to the 4th. X squared times 1, opposite product. 1 times 1. Now I look at this. Do I see any other possibilities for factoring? I do notice this is a difference of squares. I've already learned that pattern, so I should use it. X minus 1, x plus 1, and then copy the remaining factors. This is completely factored. How do I know it's completely factored? Each factor is prime. Negative 1 has no other factors. Linear, linear, quartic. This quartic factor is prime, and so this is completely factored. At this point, you should stop and try the self-assessment to see if you have fully understood this lesson on sum and differences of cubes. Okay, now we're going to move on to part 2 of the lesson, quadratic form polynomials. So a quadratic form polynomial looks like this. ax squared plus bx plus c. Keep in mind that all polynomials of this form factor in what we consider to be a normal way, where you would multiply to ac and you would add to the quantity b. Okay, for example, very simple, x squared minus x minus 6. Let's go ahead and change this to have a leading coefficient other than 1. So let's say 2 and 3. Okay, so multiply to negative 6 and add to negative 1. Okay, those are your two numbers. Now there is a leading coefficient here, so you would have to do grouping, guess and check, or some other method. Let's go ahead and remind you what grouping looks like. Okay. GCF in the first pair, GCF in the second pair, and then factor out the x minus 1 as a common factor. Okay, and then take your other two parts, 3x plus 2. Okay, you may also consider guess and check. Notice that my outer and inner terms should be right there with those coefficients. Notice 3 is prime, so I'm going to put a 3x and an x. That's the only way to multiply to 3x squared. The other choice is to multiply to get a 2. Now you only have one way to do that, 1 and 2, or 2 and 1. Okay, so let's check our terms. Notice that my outer and inner have to each have these coefficients. Outer, that would be 6, and so I'm going to go ahead and change this to a 1. And my inner has to multiply to 2. Okay, so my outer and inner have the correct signs. Let's go ahead and fill those in. Minus 3, so the minus is going to go here, and the plus is going to go here. Same factors. Okay, so let's go back to quadratic form. The reason this is in this unit is we're going to look at a higher degree polynomial. Consider if (3x to the 4th minus x squared minus 2). Notice that the quadratic has 3 terms and that this quartic has 3 terms also. What I would like to do is make a substitution in order to get this 4th degree back down to a quadratic. These are the 2 terms that I'm going to look at. Notice in this first set that the center term has the power of 1. And so I'm going to choose my substitution like this. U equals x squared. Okay, so when I make that substitution, I'm going to get minus u. Now I need to look at how do I replace x to the 4th. Let's go ahead and square both sides. Remember that x squared squared is x squared times x squared, so x to the 4th. So let's go ahead and make that substitution. Notice that we just turned this quartic, degree 4, into a quadratic form polynomial. It's quadratic form because it looks just like ax squared plus bx plus c. And then you can factor in the normal ways. Now we've already factored this one, so I'm going to go ahead and copy the factors down. Now if we started the problem with x's, we should end the problem with x's, so go ahead and substitute back. Make sure you evaluate each factor to be prime so that you know that it is completely factored. I notice that 3x squared plus 2 is a pair of terms, and there's no patterns here. No perfect squares, no perfect cubes. I do notice that this second one is perfect squares. X squared minus 1. And so you should continue factoring this. And then copy all other remaining factors. Be sure to check all factors for patterns or prime. All right, let's go ahead and try another example. X to the 4th minus 5x squared plus 4. Notice the relationship between the middle term and the first term. The middle term is where you're going to start and make that a power of 1. In order for the quadratic form to work, this first term has to have the correct power. Notice that this power is double the one in the center. Okay, so I have my substitution ready. Go ahead and factor in the normal way. multiply to 4, add to -5. In this case, the leading coefficient is 1, so it should be very quick to guess and check. Outer, inner, last. Start the problem with x's, finish the problem with x's. This particular example, I have a difference of squares in both of the remaining factors, and so I need to apply that pattern. This is completely factored. Notice that this is a 4th degree polynomial, and I have 4 linear factors. Notice in the example above, this is a 4th degree polynomial. I have a quadratic, a linear, and a linear factor. The degrees should add up to the degree of the original problem. Let's see if there could be quadratic form polynomials with a degree higher than 2. Let's make this a 2x. Okay, we're leaving the powers unknown for a minute. And let's see if we can pick out okay, what powers could we put in these two spots to make this a quadratic form polynomial? Let's assume that we have this substitution. Okay, now we're going to write this more than once. It means that the first term would be x to the 4th. So we could write 2 and 4. Is there a possibility for another quadratic form polynomial? Okay, what would you start with? Let's try upping the degree to 3. Okay, be careful. Make sure you square correctly. Okay. X cubed times x cubed, x to the 6th. Okay, let's try again. Okay, let's pick a different middle term. Always going to start here, which is supposed to be a power of 1. U to the 1st, let's try x to the 4th. Okay, u squared, x to the 4th times x to the 4th, x to the 8th. 8 and 4. Take a minute and write a statement that connects the middle exponent to the first exponent. You should be able to fill in the blank of this sentence. The middle exponent is half compared to the first exponent to be a quadratic form trinomial. Notice that this is a trinomial and that the last term is a constant and has no variable. Let's go ahead and put all of this together. Given the quadratic form polynomial, two x to the 6th, 15x cubed minus 8, factor completely. Okay, so the first thing I notice is that I've got a trinomial. And I see that I'm skipping powers and that the middle term exponent is half of the original. Okay, so I'm going to go ahead and define my substitution. You always start at the middle term, making that the power 1. And then we see how that substitution is going to work out. Go ahead and substitute. 2u squared. And factor normally. Okay, so multiply to -16, add to -15. Okay, now you can do guess and check, you can do grouping. Go ahead, press pause, and create the factors. going to go ahead and do guess and check because I noticed that 2 is a prime number. Okay, so I'm going to put my 2u and my u. So I've got my first. Notice that these two numbers are still going to be your outer and your inner. Okay, so my outer, I need to get up to 16 or 1. And so I'm going to put an 8 here. And then my inner needs to be a 1. Okay, so let's check my signs. Minus 16 and plus 1. Okay, 2u squared minus 16u plus 1, check, minus 8. Okay, I start with x's. I need to go back to x's. 2x cubed plus 1, x cubed minus 8. Okay, before you're finished, you have to check each of your factors to make sure that they are prime, and you cannot do anything else on our factoring flowchart. Okay, just for a reminder, do we have any GCFs? No. Do I have any pairs? I don't see any perfect squares, but I do see a difference of cubes. X cubed and 8 are perfect cubes. Notice here that even though x cubed and 1 are perfect cubes, that 2 is not, and so the pattern does not apply. Okay, so I'm going to define. Okay, there are my bases. Okay, so we copy. Okay, stops. All right, tap, tap, x squared. Tap, tap, opposite product, tap, tap. Okay, and then copy down the remaining factors. This is completely factored. Okay, stop here and try the self-assessment where you can find on Blackboard. Continue on to the next portion when ready. We're going to go ahead and move on to the third part of our lesson today, which is grouping. Now, you have likely done grouping before when factoring with quadratics, but we're going to go ahead and move that up to 4 terms, 6 terms, or 8 terms, because grouping can actually be used for any even number of terms. So when you are dealing with a trinomial, you typically split your middle into 2 numbers that added up to the middle number so that you would have 1, 2, 3, 4 terms. And that's when you applied your grouping. Okay, so we're going to go ahead and we're going to start with problems where grouping is actually already applicable. Okay, so any even number of terms. So we're going to go with 4, 6, 8. Most of ours are going to stop with 4 or 6 terms. So here's our first example. Okay, 3x cubed minus 2x squared minus 6x plus 4. In order to use grouping, you first have to have an even number of terms. You're going to split the polynomial evenly so that you have the same number of terms in each group. And then you're going to look for GCF twice. Okay, what's common in the first 2 terms is an x squared. Okay, and what's left is 3x minus 2. Notice that the sign is included with the term, and so between these two there's a common minus 2. What's left? 3x, careful with the negative. Negative times negative is positive. Now, what you do next, so that was the first GCF. The second GCF is what's common between these 2 groups. It's this factor right here. This factor is common. It's called a binomial, 2 terms. Okay, so we're going to take the common factor in front. Then you're going to write down what's left. Okay, so we did GCF once, twice, and then 3 times. Before you are finished, you have to go ahead and look at each factor to make sure it's prime. 3x minus 2 is prime because it's linear. When you look at quadratic factor, you check your factoring flowchart. Okay, I've done my GCFs. I am looking for patterns. Why am I looking for patterns? There's only two terms. Pairs of terms are typically patterns. I notice that they're not perfect cubes. I do have a perfect square, but 2 is not a perfect square, and so patterns don't apply. This is completely factored. Let's go ahead and you try the next example. Press pause and then check your work. 3x cubed minus, oh, sorry. Okay, just kidding. You already did that example. Let's go with x cubed plus x squared minus x minus 1. Okay, press pause and then factor. There's a common x squared. Here, there's a common negative 1. The GCF is the x plus 1, so I'm going to factor that out. Hopefully you notice that there's a difference of squares pattern, and you factored again. And then copy down the remaining factors. Notice that we actually have the same factor written twice. Go ahead, use a multiplicity of 2 for that factor. Okay, let's try another example. This one's going to be slightly more complicated with a few extra letters. Okay, so let's go ahead and there are 4 terms, split it down the middle. And let's look to see if there's anything in common. One thing you can do with the numbers is you can look for the same ratio, 5 to 2, 10 to 4. That also applies for the examples that we did earlier. 3 to 2, 6 to 4. 1 to 1, negative 1 to negative 1. That common ratio will help you determine if there's going to be a grouping available. Okay, so I notice that there's a common x squared, leaves me with 5x plus 2y. Positive. I notice here that there's only a common 2, but there's also a common y squared. Leaves me with 5x plus 2y. You know that grouping works when this remaining binomial is actually the same. If it is not the same, then grouping did not work, and you should go back and reevaluate your efforts. Okay, take the common factor in front. Copy down the remaining terms. Look at each factor to make sure it's prime. Linear, prime. Okay, I see a pair of terms. So again, I'm going to check my factoring patterns. Okay, do I have a difference of squares? No, I see a perfect square, but 2 is not a perfect square, and it's a plus. So there's no factoring that can be done because they're not perfect cubes. This is completely factored. Okay, let's go ahead and put it all together. Okay, so for the next example, let's go with something that has more than 4 terms. Okay, so I have 6 terms here. And when I'm looking for grouping, I'm looking to split them evenly. I'm going to look at the ratio of my coefficients. Notice it's in order. 1, 3, 2, negative 1, positive 3, negative 2. So I notice with these coefficients that if I group it into 2, this might yield something that works. I don't know until I try. Okay, what's common in the first group of 3? X cubed. Left with x squared minus 3x plus 2. Here, if you think nothing's in common, it's either 1 or negative 1. In this case, the leading negative means negative 1. Switch the sign. Okay, check your factors. is this factor the same as this one? X squared minus 3x plus 2, x squared minus 3x plus 2. Yes, that means it's a common factor. Pull it out front. What's left? X cubed minus 1. Make sure to check all of your factors to see if they're prime. Okay, can I multiply, right, quadratic, trinomial. Can I multiply to 2 and add to 3? I can. Okay, so continue factoring. Okay, pair of terms. Okay, check my flow chart. Pair of terms. Is it a difference of squares? No. It is a difference of cubes, so I'm going to define my bases. Okay, and I'm going to use my pattern. Okay, so I set it up. I copy the factor with the bases and the same sign. Okay, and then I'm going to touch the paper to help me remember my formula. Square, opposite product, square. Linear, 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 quadratic. This quadratic from the cube formula is always prime. Now I notice I have a repeated factor, so you could use a multiplicity to write that in a different way. Both ways would be accepted. Let's go ahead and look at our last example. This time we're going to have 6 terms again. Okay, so I'm going to look at my coefficients. First, I'm going to consider splitting it into 2 groups. 1, 2, negative 1. Negative 2, negative 2, negative 4. The ratios are not the same, which means this grouping is not going to work. Okay, could I group this any other way? Now, the reason you have to have an even number of terms is you just have to be able to group them in a similar way. So let's do 2, 2, 2 instead. 1 to 2. Negative 1 to negative 2. Negative 2 to negative 4. And that grouping actually does have the same ratio for the coefficients, so I'm going to try it. Common x to the 4th. Common negative 1. Oop, negative x squared. Okay. Common negative 2. And then I notice that I've got a common x plus 2 in each grouping. So I'm going to factor out, okay, x to the 4th. And then I look at each one to see if it's prime. Linear is prime. Okay, this is a quadratic form polynomial. So that's u squared minus u minus 2. Can I multiply to negative 2 and add to negative 1? I can. All right. U minus 2, u plus 1. But if I start with x's, I have to end with x's. Okay. X squared minus 2, x squared plus 1, and copy down the remaining factors. I do have to check each factor to make sure it's prime. Linear. Okay, check my patterns. It's a difference of a perfect square, but 2 is not a perfect square, so this one is prime. And this is a sum of perfect squares, which is prime, so this is completely factored. Go ahead and try your self-assessment on Blackboard. I hope you enjoyed this lesson.